Alright, you guys, we're talking about the acid and base unit. First of all, we're going to start by naming acids. This is something you already know how to do. You learned how to name acids in the ionic compound unit. So go back on modules in Canvas and find the module for ionic compound unit and look at some YouTube videos that have information on how you should name acids. Look at the acid nomenclatures. Look at the flow chart that I gave you. Some of you should have it, if not all of you should have it with your reference charts. But there are some things that I didn't talk about naming acids, and those are the facts that I'm going to cover today. Naming acids, you guys, there are several different types of acids, and all those acids depend on the number of hydrogens that are present. So you know that an acid always has a hydrogen in front of it, but counting the number of hydrogens also affects the name of it. There is something called monoprotic. Protic means hydrogen, and mono means one. So these are acids that only have one hydrogen in them. Like hydrochloric acid, this has one hydrogen only. Then there's something called polyprotic acid. Poly means many. Protic means hydrogen. So this is having many hydrogens attached to the anion. One of these, polyprotic, is called a diprotic. Di means two, so these are two hydrogens. A good example of this is sulfuric acid. Sulfuric acid, it is H2SO4. This 2 represents that there are two hydrogen ions that are present in this equation. Triprotic is another one. This is 3 hydrogens that are present. A good example is hydrophosphoric acid, where 3 hydrogens are present. And all of this information, you guys, is good when we start talking about the strength of the acid, because this really, the number of hydrogens helps determine how it dissociates in water and how many hydrogens will separate from it. Another way to name acids or to classify is through oxyacids. Oxy means oxygen, so these are acids that have an oxygen group attached to it. Usually this is an anion, and the anion is usually from the polyatomic chart. A good example would be nitric acid. Notice that nitric acid has an oxygen group attached to it, so it would be an oxyacid, and this happens to have 1 proton, so it'd be a monoprotic acid also. Your binary acids do not contain oxygen, and they usually are, the anion is usually from the periodic table. Binary, don't forget, means 2, so they're usually 2 elements or 2 elements that are attached. Hydronitric acid is a good example of it. This is a binary because there's 2 elements that are attached to it. But notice how many hydrogens there are. There are 3 hydrogens, so this would be known as a triprotic acid. The next thing that I want to talk to you guys about is the characteristics or the properties of an acid. Now, of acids and bases. So acids, you guys, you know them to be sour. If you've ever had a Sour Patch or lemon drops, then you know that they taste sour. But if you leave them on your tongue for too long, your tongue eventually gets a really rough feeling. That's because acids have they're very rough to the touch. Another property is that hydrogens are usually in the front. They're always in the front for acids. The pH for acid is from 0 to 6.9. Realize, you guys, that 7 is neutral for both acids as well as bases. 7 will be neutral. When acids dissolve in water, you will get the hydronium ion concentration will be a lot higher than the hydroxide ion concentration. Your blue litmus paper, when it comes in contact with an acid, will then turn in red. And think about red, the color red as in red danger. So your blue litmus paper turns red when it comes in contact with an acid. Acids also conduct electricity because they're electrolytes, and they react with metals to produce hydrogen gas. They're also corrosive. Now they donate protons. This is really important when we start talking about Bronsted-Lowry theory. Maybe in the next lecture. And they also neutralize bases. Your properties of bases is that they are very bitter to taste. And if you've ever gotten soap in your mouth, then you know that soap is also very slippery. It's slippery on your tongue, it's slippery everywhere. So that's a very, very distinct characteristics of it. Bases, you guys, also they always end in OH, which is the hydroxide group. They usually end in OH. There is an exception, which is ammonia. Ammonia does not, notice, have an OH group, hydroxide group attached to it. Nevertheless, it is still considered a base. The pH range for bases is from 7.1 to 14. You will never find 7 describing an acid or a base, because that means that it is neutral. When bases dissolve in water, they are hydroxide, and in this case, the concentration of the hydroxide is greater than the hydronium concentration. So the hydronium concentration is less than the hydroxide ion concentration. The litmus paper. Now, instead of using a blue litmus paper like you do for an acid, you're using a red litmus paper. And when that comes in contact with a base, it turns blue. Just like acids, bases also conduct electricity. And think back to when I did that experiment in class where I used a light bulb. I put it inside different solutions. Remember, you guys, that I did use an acid and I did use a base, and our light bulb did light up. So go back and look at your notes. You guys should have it somewhere written down. Strong bases can also be very harmful, just like strong acids. So in fact, bases, if you get your hands in a strong base, your skin does come off. So that's a myth that people think that bases are not as harmful as acids. They are. They do neutralize acids. And number 10 is super important, just like it is for acids, that unlike before for acids, bases now accept hydrogen. So that is going to come in handy when we start talking about Bronsted-Lowry theories. And also, you guys, bases react with oils and greases. That's why they're cleaners. And technically, soap is considered a base, but because it's so rough on your hands and it's so slippery, your skin, if you work with soap, really the industrial soap, it makes your skin very rough because it is taking off that skin. So instead now, most of the soaps that we have, dishwashing soaps, are pH balanced. So you probably have a soap at home and check to see, but it is probably pH balanced to 7. So when you touch it, nothing happens to your skin. Here's a pH scale. Notice this is neutral once again, and it's got different items here that tells you the pH of those items. Anything above a 7, from 0 to about 6.9 is acid, and then 7.1 to 14 is a base. Here is a list, you guys, showing you all the bases and the common bases and the common acids that are available. You may not think so, but orange juice happens to be a 3.5. And then if you don't know, let's see, what would you know? Blood. Blood is basic. Not too basic, but it is basic. It's 7.4. So this would be the acids. These would be the common bases. This concludes, well, I think I'm going to go ahead and talk about Bronsted-Lowry for you in the next lecture. But this concludes our talk for today for naming acids and the properties of an acid and a base.